it's time to look at waves. Waves are important because they transport energy from one spot to another. Okay, so that's how we get our energy from the sun. That's how we can transmit information through our spaces and so forth. So we're going to study waves, all right? So waves can be defined easily as rhythmic disturbance. Okay, so rhythmic disturbance means a regular pattern, okay, that carries energy. Okay, that's the key thing, carries energy which can cause change through a medium. Okay, and by this case, what is a medium? Medium is anything that wave can travel through. Okay, so air is one. Okay, sound waves move through the air. Okay, water waves, that's evident. Waves crash, they bring in energy, can knock you over. Surfers use them to move. Earthquakes create waves. Okay, waves are traveling through space. Some waves can travel through space, some things can't. So we'll look at that a little bit later. Stuff like light can travel through empty space. Sound cannot. All right. So waves are broken down into two basic types. One is called transverse waves. Okay, and the other is longitudinal or compressional waves. Okay, so if I was to ask you to actually draw a wave, most people would draw a wave. It looks something like that because it's kind of like a water wave. We're really familiar with that. By definition, a transverse wave, the particles move at right angles to the direction of the wave. So if the wave was going this direction, okay, the actual particles would just be going up and down. Okay? They don't actually go with the wave. Right? It's being transmitted through those particles. So think about a little cork sitting here in the water. Okay, as that wave goes by, that cork basically just goes up and down. Okay, so the waves move through the material. They don't actually move that material from one spot to another. All right. So some things about waves you should know. First of all, the top of the wave is the crest. Okay, and the bottom is the trough. That's pretty simple. Okay. Now here's some terms you may not be as familiar with. Wavelength is given this sign lambda. It's from crest to crest. Easy to remember, crest to crest. Okay, so from top of one wave to the top of the next wave, that is called the wavelength. Okay, it can vary. You can have waves with very short wavelengths. You can have very long wavelengths. Next one is amplitude. Amplitude kind of measures the energy of the wave. The bigger the amplitude, the more the energy. It's from rest to crest. Okay, so you think about this wave here. You can almost think of like a nice calm pond. Okay, nothing's going on. It's just nice and calm. You throw a rock into it, of course, it creates, that energy is transmitted from that rock into the pond, and it creates a wave. Okay, so if you measure from that resting position to the crest, okay, that would be the amplitude. So amplitude is how high it goes up. So if you throw a little pebble in, you're going to make a little wave, just a little bit of energy. If you think a big boulder in, then it's going to be higher, right? So amplitude measures from rest to crest, that's the energy. Okay? The frequency is the number of waves per second. Okay? And of course that can vary. So the number of times this wave goes up and down every second. That would be called its frequency. It's measured in a unit called hertz, or Hz, or waves per second. Okay, and then of course waves have certain speeds or velocity, wave speeds. Okay, and for a particular wave, it's equal to its wavelength times its frequency. Okay, so you also know waves, velocity is also equal to distance over time. Okay, but you can also figure it out by wavelength times frequency. If you're given a certain wavelength and know its frequency, you multiply those two together and you can get the velocity of the wave. All right. There's one other type of wave. It's called a longitudinal or compressional wave. Okay, so it's a little bit different. Okay, it still transmits energy and it's still a regular pattern, but instead of the particles moving at right angles like a transverse wave, the particles actually move back and forth like this. Right? So what it creates is a compression and a spreading out, or they call it a rarefaction. Okay, so compresses, spreads out, compresses, spreads out, compresses, spreads out. Okay, so the wavelength would be from one compression to the next. Frequency would begin the number of times and back and forth every second, number of oscillations. Okay? So for example, sound is a longitudinal wave. It's got a certain speed, and of course you can have different frequencies of sound. Okay, so we'll study that later in the week, but you increase the frequency, you're going to change the wavelength. Okay, so I have a little demonstration here. I got a spring which can show waves here. So I'll put a little tension into this. And then if I give a little back and forth motion like that, you can see I'm transmitting energy to the other side. Imagine someone trying to hold that, their hand would move. Okay, so that would be a transverse wave there. Okay. If I wanted to make a compressional wave, I could just draw this straight back like this and then let go. And you can see the energy being transmitted through there. I'll get a little more tension. You can see the wave travels there. It's still transmitting information, but it's doing it longitudinally or in a compressional wave. Now, to show wavelength and frequency, I can create like a standing wave here. If I just give a nice, slow, I increase it a little bit, you can see the crest going up and down. Okay, so I got a pretty low frequency, long wavelength. Okay, now if I give it more energy, okay, the wavelength and the frequency may stay the same, but it's going greater up and down. Okay, so it's got more energy, it's got greater amplitude. Okay. And if I actually take that and I go quicker, okay, watch, so it's increased in frequency, you can see, okay, the wavelengths are shorter and frequency is greater. Okay? So I can actually try to go really quick. Let's see what happens. You can see I got higher frequency and the wavelengths are shorter. All right? So those are examples of transverse and longitudinal waves, which we are going to study more in depth this week.